So hi guys, it's me Deepak, and in this video we'll be building a program that is gonna show us what is backtracking. So if you're familiar with the algorithm, so if you're not familiar with what is backtracking, you basically look for a solution, and if at a point you constantly reach to a solution, and if at some point you realize that this way of reaching to this way that I'm going is not going to take me to a solution, you backtrack and go the other way or the other option that you have. So that's basically what is backtracking. But we are gonna do a question here. We're gonna have like a queen's problem. We're gonna on a chessboard. I will be first building a 4x4 chessboard. I'm gonna be placing 4 queens on it, and I'm gonna be placing queens in such a manner that no queen is in reach of other queen or is capable of attacking other queen in that particular position. So you know how a queen moves, right? The horizontal, vertical, and diagonals all the way. Okay, so I don't want to put a queen in the reach of the other queen that it can attack it. Uh, so that's what I'm gonna go, and I'm gonna do such a manner that I'll be using backtracking. So if at some point, let's say I place like 3 queens, one, two, and third, and at the third queen I realized that, oh shit, I cannot, like, there is no way for me to put the third queen in such a way that the other 2 queens won't attack it. So what I'll do, I'll backtrack to second queen and then replace it in such a way that first queen is not going to attack it. So I'm going to be building from first queen, then placing second queen. When I'm placing second queen, I'm going to make sure that first queen is not attacking it. When I'm placing like third queen, I want to make sure that the first and second queen is not able to attack the third queen, and same as when I'm putting a fourth queen. But that can be a little bit complicated for some people. So what we'll be doing is we'll be visualizing the queen pose, because it is really easy to look at the code and so on geeks. So that's where I'm using the base of my code, like about how the algorithm works. But what I'll be doing is visualizing it in front of you right now. So let's do it. So I'm gonna start with just opening a terminal here. Oh, I need to breathe. Okay, so let's create a folder, and I'm going to name it visualizing. I'm thinking about starting a new series where I'll be visualizing a lot of algorithms. Let's first get into desktop. So what I'm thinking about doing is starting a whole series, because I already have 2 videos visualizing quicksort and ace algorithm. Not sure, but so let's make a folder first. Visualizing, and we have a folder. Let's move into the folder, and let's create a file. Let's name it backtracking.py. Okay, so let's here, and this is a file, and I'm using Sublime Text Editor. I use editors, not the IDs, because IDs are really helpful too, but they make it really easy for you to code. Like, you don't have to remember any particular line of code. Like, if you were just type like few alphabets, it knows what are you going to do. So it makes no sense for me to just remember the code. You tend to forget it. So in editor, the code remains in my mind, and it's easy for me than if I want to code on someone else's computer who doesn't have a IDE. Or in college, well, I used to, but now it's been for a year since I've been to college, almost. So what we okay, sorry. So first we're gonna have like a global variable n, and n is set to 4. So I'm gonna have like 4x4 chessboard at start. And half of you have seen this code on Geeks for Geeks. This is I have used the base as what they have shown. So it's going to be the same way. I'm just going to explain what is going on. So I'm going to go really quickly over what I'm doing. So, and then we will visualize it. Okay. So I'm getting a function here, solve enq, calling a function solve enq. So first let's create the function solve enq, the hell. Okay, so what we want is board, and we're gonna create like 4x4 board. You know how it goes, like so. And every board, the queen, whenever a queen occupies space, it will hold a value 1. Otherwise, the path is traversable, so it will be 0. So I need a 4x4 matrix. So let's create 0, 0, 0, 0, comma. Let's copy this. So initially I have an empty chessboard, and I will be placing queens one by one in a recursive manner. So what I will do is I will first see if the path is traversable or not. If it is not traversable, so let's call a function that I will be creating, and we'll be seeing if queen can, if there is a solution available or not. And this function is also gonna help us find a solution as well. So it's gonna return a boolean equal to false. So let's put how where I'm gonna start 0. It is necessary to have like you know how rows and columns work in the pygame, right? Like the first, like when you mention something like I think I should explain this first. This will be helpful then. So like while editing this video, I saw that I have like made it a bit confusing to understand what I'm talking about when I'm talking about rows and columns being interchanged. It's about the pygame window, not like about how matrices work in Python. I was a bit confused while explaining. I was just a bit tensed, so I made a mistake there. So it's about the pygame window, not about like Python. I mentioned it in the video, but I made a mistake. So so please remember, this is about pygame window, not about the Python. That's what it's. Let's continue. The board, this one, like if you put like 2 here, it's gonna be like 0 and 1. So it's gonna be like here, this particular where, like if you put like 2 and 0, so this is gonna be representing 2 and 0. It's gonna, or 1 and 0. I will start from 0. So this is gonna represent this, like so. The first bracket represents the columns, and the second one represents the rows. Yeah, I know it's a bit confusing because like in maths it's the other way around, but here so it represents. Took me a while to get that, or I should say some errors to get that. If it's false, like if there is no way, because I'm going to return a variable from it, I'm just gonna then print that there is no solution. So I'll say solution does not exist. And otherwise actually also I will return from here as well. So if there is no solution, then just return false, else I will be printing the solution. Yeah, I know I'm too lazy to even change the names of the functions and variables, but what can you do? So but at least I'm visualizing it, so I'm improvising the code. So I hope it doesn't come under pleasure, like like just copying the code. I am putting some effort into it. So let's create the function. Sometimes I get the error where I just name the functions wrong, so just right. Let's give it board, and I'm thinking about putting board out of the function. No, but we will do it later. So what we want to do is, so we have board and we want to put the solution. Let's create 2 loops for I in range n, and for j in range n. What we'll do is print board I j comma and equal this, and after every time I'm just gonna, so that I will uh, I hope this is necessary, and this will print me the solution. This is gonna print me the board and how the queens are placed. So where queen will play, it will be like 1. So let's say this is was where the first queen should be placed, so it will be 1. If this is where, or this is where third queen should be placed. This is where third, or this is where fourth. This is how we're gonna place it. But we forgot to create our solution in Q2 function. So let's first create that. Solve NQ U till, and we want board here as well as column, because we're going to call this function recursively. So like if we create first if you create like first, for first column we will check, then we're going to recursively add column 1 and then again call this function. Like when we, well, let me show you first how it's done, then we will get it to it. Okay, so first of all we should check if we have reached the solution. This should be the base priority, if you have already reached the solution or not. So for base solution, check if we have reached the solution. If how are we gonna check if how can we do it? We're gonna like write an if condition if column is greater than equal to n. That's it. Okay, it should be capital N. And if we check if we have already like so after like so there are 4 coins, it should be placed like first coin will be placed in this column, second in this, third in this, fourth in this. Then if we have already placed all the 4 columns, because we're going to recursively call this function again and again and again to break out of this function, we will check if column is greater than or equal to 4. So 0 1 2 3, so 4 basically means we have already placed all the 4 coins, and we have to come out of this function. So we will return this, we will return true, so that we doesn't encounter this return false, so it doesn't encounter this condition, and return and say that solution exists. So we will return true. Nice. Second thing we have to do is to create a for loop. This is gonna help us iterate through the, I think I missed something here. And write a function so I can visualize it, because that's what you are here for. I think I should have given the timestamps as well. Sure. So what is this is safe? Like there's no way that the previous queen is gonna hit it. So like there is no way that the previous queen can hit it. So it's safe. You're gonna have like board I and a column, and what we want is we're gonna give it the row in the traditional sense, the column and the board. So this is where we're gonna place our queen that we're gonna place now. So like the base case is gonna be first queen, second case it will be second queen. So we are thinking about placing it at that particular row and column, and we're gonna see that if there is a way to place it. Like there's nothing like how should I say this? Uh, this is not like you're gonna like hit the queens, hit the it comes in the way of previous queens, or it's gonna hit the previous queen, so it doesn't come in the range of those previous queens that you have placed earlier. In the base case it doesn't matter because there is no queen, but second, third, fourth case there are 1 2 3 queens, so you have to be careful about not placing a queen there, and that's what we will do. We can do is first let's create the is safe function or not, so it become more clear to you. Is I'm actually making this because I have exams and I want a break, and I'll post it in between the exams so I don't have to make a video. We have board, we have row, and we have column, and what we want is for I in range n. So we're gonna create two loops for I in range n, for j in range n. We're gonna see if it like wait a minute, we don't need two loops here. Okay, we only need one row now. We basically have to check it for columns. Oh shit. We need like columns here. We will check for columns first. So for I in range columns, we're gonna see if like, how should I say this? So what you're gonna do is you're gonna check it in the line that like if we have like a a queen in the same, like in the rows, because we're gonna moving from column, so it's not like the two queens are on the same column. uh, it is getting a bit confusing. Let me explain like this. You're not gonna have a queen like this in the same column, but you can have queen like this, like in the same row. We don't want that. So that's why I will be placing a for if condition for I in range. If I already have one here, like if there is one queen here, then I don't want another queen here because it can easily come, this queen can hit it. So I don't want that. That's why I will first checking if they are in the same row. That's make much more sense. Thank you Pygame for making it a lot confusing. Let's move on. It's not like Pygame fault, it's Python fault. So if I started really like it's confusing how it works, but once you get what is happening, it's not that confusing. So row is basically column and column is basically row. That's what it means. Then return false. Okay, right? Yeah. Actually, I have a code on the second screen as well, so I don't mess this up, and that's why I keep stopping in between just to check I'm not making any mistakes. So I have like a zip, and what I'm going to do is now check for diagonals. First, I will check for like in the like how should I say this? First, let's see if there is queen here. Then I will first check for this path. So let's say I have one here. Then we check if there is a queen or there is a queen. So I will first place one here. So -1 -1. If then I will check for downward. So then I will have lower diagonals on the left side. So for then I will have columns will be negative again, but then I will be checking for, wait a minute, -1 -1. Let me first code it, then you will get what I'm trying to say. So zip is going to have help us like loops range row -1 -1. So it's gonna go from like row, whatever row we are at, to 0. -1 basically means like behind that, and we are decrementing it by 1. So for I value, and then we're gonna have it for the j value as well. So let's have range, and what we want is column -1 -1. This is gonna be our range, and we check if board I j is equal to 1. If it is, then return false. So that sums it up. And similarly, this was going rows are like columns, so you are just going like in negative direction. Like when you have negative direction, you actually are going up in case of rows, and in the left side in terms of column, like positive points are going down in terms of rows and right in terms of columns, because like have uh, you have like this is how rows goes. So this is like 0 1 2, so this is downwards. It's a bit confusing when you compare it to the Cartesian plane that you have seen, but what can we do? So similarly for downward, so we are decrementing -1. So when we're decrementing it, we're going upwards. That's why it is for the upper diagonals. And when we increment this row, we're gonna have it for the lower ones. And that's what we're going to. So let's just copy paste it. It's just wasting time now. So what we can do is change it from row to end, and not -1 +1. Yeah, and columns will again be negative. Uh, and so we're basically like going backwards, because there is no queen in not going to be a queen in the other column, because there is no one. This is the column that we are placing first queen in the we are placing a queen in that, and before those columns we already have placed queens. So we're going to check for what is behind that, behind what queen is behind the particular queen that we are trying to place. We haven't figured out the position for the current queen, but we have figured out the position of the previous queens. But that position of queens can also be changed, because we are calling this function recursively, and if it returns it, this is basically done. This is what you have to do. You have to check for horizontal, then for upper diagonal, then for lower diagonal, and if it is if there is a way, then we're gonna what is this? We're gonna set the position of board. So we haven't set any. We haven't placed the queen yet. We were just figuring out. So if we figure out a way that yeah, you can place it there. This is a safe way. Then we're gonna like so in that particular just say this. So we have to place it like in the first column, like this one, or like this one, this one, this one, this one, and we are iterating in that column through this I. So for column 0 I0, column 0 I1, column 0 I2, and column 0 I3. So here, wait a minute. Yeah, we are doing it right. That's how it's done. And then we're gonna recursively call the function again, and column, and we're gonna set it to, if it is equal to if it returns true, that means so we're going to recursively call this function, and it returns true only when the column is returning true. So when the column is incremented by true, it will return true, and whenever it returns true, we will return true as well. So for the fourth case, when n is incremented, when n is set to 4, we forgot to say like this. So this is where we're going to increment the column. So this is for first column, or this is for second column. So when after we have placed a queen here, at first we're going to place queen here, then we're going to move to this one. We're going to say like we're going to place like queen here or here. We're going to place it like this one. Whenever we're going to place it on this one, we're going to increment again column by 1 and call this function. So we're going to recursively call third. For third, we will see where we're going to place it. For fourth, we're going to see place it. After we have like 1 and column is now 4, so it is equal to n. Now we return true. Then it was so it will return true here for the for this one, this particular case. It will return true from here as well. Whenever it return true, we will go here, and after we have successfully ended to this one, we will first call our recursive function. It will also return true, and we will go here. in this function. So we'll be calling like from here to here to here to here, and then the control will shift backwards from here to here to here, and then to this function solve and queue. So we return true, and if it doesn't, and if it's not, like if it doesn't return true, that means there's some issue here, and we will again set the board to false, because we're gonna eventually encounter a case where let me show you. So we're gonna set it equal to 0 in case if this two condition doesn't occur, and if it returns false, so we're gonna set it to 0. Let me show you how. So let's say we place queen here, because there is no reason not to place queen here. Then we're gonna place here, we will return queen 1 here. But then we're gonna place it like here, we cannot place it here, so this is gonna come directly here, we're gonna place it here, and we're gonna place it here. So what we'll do, we'll jump backward, turn this to 0, and we'll see where else we can place it here as well. So we're gonna place it here, we're gonna see we cannot place it here, we can place it here, so we're gonna place it 1 here, we're gonna see 0, we're gonna place it here, cannot place it here, cannot place it here, and cannot place it here. We're gonna jump back, turn this to 0, we're gonna see we're gonna move it further, turn this to 0, and change from here as well. So we're gonna change it to 0 as well, and look, change to other values, like this is gonna be 1, then we're gonna see where we can put it, this is like 1, then we're gonna see like this is gonna be maybe 1. So you get my point, like if there is no way to change it, we're gonna just return false, and after every time like even after this loop we haven't figured out a way to return true, we will eventually just return false. So return false, that's what we're basically doing. I think I messed up with rows and columns, I'm just gonna edit it out. Okay, we have the whole code now, I think. Yep, we basically have the whole code. Now it's only just the visualization left. Python. What? So it doesn't exist? How come? Okay, okay, I can see now. We are not even returning true at here. If we don't return true, how are we gonna see it? Let me see. Yep, as I predicted, one here, then here, then here, and then here. But this is like easy stuff. Anyone can do it. By looking at code, I mean, I did. Uh, so what we can do is just to begin import pygame, pygame dot init, and what we can do is we need a way to have like the infinite loop that we want so that our windows remain stable, and we need a window. So let's just create a window. We have like pygame dot this display dot set mode, and we're gonna have a screen size of 800. This is pretty much how I now create my loop. So let's have a main function here, then we're gonna have like def main, come on, and you're gonna have like run, which is equal to true now, and we're gonna have like a while loop, while run, and we're gonna have like for event in, this is the standard stuff how you create a way to close the window. Pygame dot event event dot get, we're gonna see if event if event dot type is equal to pygame.quit. If it is so, then just okay, I forgot to put a condition here. Then we just want run equal false. We're gonna have a draw function here as well that we're gonna recursively call. So draw, and what we want is a board to be here. So let's copy this board. We're gonna send board here, board, and what you can do is have board here. Let's copy this and call our function. Also create like if event dot. How do you call the key function? Key inputs. I literally forgot how we call key functions. It's event dot type. If event dot type is equal to pygame dot key down. Pygame dot key down, and if event dot key is equal to pygame dot let's say key space. So we have a space key, and then we're gonna uh, call this function, and I'm gonna pass board here, and then we're gonna call this particular function. There actually no need to call now this function, but let's keep it there. I don't want any mistakes. Let's create a draw function where we're gonna pass our board as well, and let's create board function. Let's create it at the top. It'll be easy for us to see. So we're gonna have like def draw. We will be passing board here, and what we want now, we're gonna first create a window just like this. Let's copy paste this, and we're gonna have squares. So we're gonna draw three different colors of square: white, black, and red. White is when there is no queen, black is when there is queen, and red is for the path, the scanning, like the scanning the code does when it is looking that there is no queen attacking, there is no queen that can attack it. Okay, how we're gonna do it? Very interesting. First, let's fill the window with white. So window.fill, and we want to white, so 255, 255, 255. This is the color for white, and we're going to do is for I in range n, what I'm doing, for j in range n, we're going to have like if board ij is equal to 0, draw white squares. So how do you draw white squares? It's really easy. Pygame dot, it's this command pygame dot draw dot rect. We're gonna have a window, then we have to define the color. So color is 255, 255, 255, and then our screen size. So we're gonna have like I into 200, comma I into 200, j into 200, and comma 200 as our length and width. Pretty standard stuff. And similarly, just copy paste this code for black and red as well. So if we encounter like let's say red, or if we encounter like one, that means it is the queen is there. So let's have like one changes to like 0 0 0 0 0 0 is for black, and 255 0 0 is for red. Okay, and also we're gonna have like pygame dot, this is one of those errors that I get when and I get stuck, like I don't know what the hell is wrong with my code, and I just forget this particular command to write. And it's really like irritating when you have this particular code and you really don't want this code, because why would somebody want this code? But it is really irritating when you get an error like this and you like spend like half an hour here and then figure out like there was not even an error. And let's call draw function few more times here and there, like here. This will tell us how the particular is added or removed. We can see, and I know I haven't added 2 yet for scanning. We'll do it in a while, but first let's import time so we can slow it down. Import time, and what we want is somewhere here. Let's do it like clock equal pygame dot time, the hell, time dot CK, and we want like time to be what I say, clock dot tick, and let's add 5 here. It's going to really slow it down, and I want similar code here as well. So wait a minute, this should be here. I should, what the hell is wrong with me today? Come on, C and clock dot tick 5. This is going to slow it down, and then you can see the code. Okay, so you know about like uh, if I get 1, I will just return false. But if I get 0, that means I am checking if there's 1. So that means it comes on the scanning, right? So what I will do is I will just do is board board I board row I equals to, then I will do is draw BOARD, and I will do is like clock. Let me just call clock here. CLOCK equal pygame dot time dot clock, and you can just do this CLOCK clock dot tick equal 5. And after that, when I'm through with this, I'm just going to write a for loop condition for j in range column if board column if board row j is equal to 2. That means it was earlier 0. I will just return it to board row j equal 0. And this is the pattern that we're going to follow. We'll just see if so like here I'm going to print this one, but I and j here, and if I return false, I will just create the same for loop condition like this one here to convert it back. So I will just write here x y, and what I will do is I will just do a simple I'll do a simple search for x and y. If x and y is equal to 2, then x and y is equal to 0, and the same step has to be followed okay here as well. Let's return this, and also this thing as well here. So let us uh, okay. Remember what I said earlier about how columns and rows are uh, switched? Just look at this now. This is 1 is here, 0, 1. When it is drawn, it is here. It is at like 2 1 position, but it should be at like 1 2. Similarly, this one should be like at this one nothing to like happy about. I'm getting an error, but at least I was right to start when I was like placing it. Oh, that feels really good. Like I was right halfway through. Like I mean, I remember like there was like a bit of switch between ing positions, but where I didn't remember. Like I messed up. I messed up like, big time this time, but at least I was right. That is really good. And what to do is I have to do a check uh, for I should like maybe like this will fix it. Not sure. And I also have to remove the ing that I'm getting, that two value that I'm getting. That I have to change. Why isn't it canceling? What is wrong with this thing? Uh, please be right. 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 No, what the hell? Please be right. Okay. I think we have got this one. I think we have got this one. Yep. Right. Yes. Bullseye. Okay. So we have finally figured out the answer for this problem. Actually, I just like wasted like half an hour figuring this out. I'll just cut it out. But I usually like half an hour figuring out why, but the answer I was getting earlier was not right. So I first let me just remove these zeros, these uh, these twos, or let me just make it a bit bigger first. Okay, and then I will just wrap this video. What I want here is change this a bit. So we have like this thing now. It has like 8. Similarly, I'm just going to command C this one. How many I want? I want like 7, 8. Nice. And here I have to change it everything to 100. Scaling it to right sides. And that will make it a bit better. And in the print solution, what I will do is I will run like to loop for I in range and for j in range, and if board, okay, board I j is equal to 2, then what I can do is I will just set the value to I can't with this. Where was I will just set it to like 0, and this will do it. and now you can see it in 8 cross 8, and it's going to take a while. So let me just comment the slowdowns, otherwise it will take an eternity. And it's really cool when you just speed this thing up a bit. So I have like 5 slowdowns here, and okay, it is still trying to find out. It will never. Just close this up and let's see it now. Yeah, a full speed. I hope it is full speed, otherwise my computer is a bit slow. When I read it on the laptop, it was pretty fast there, but that is work. I don't know why my friends keep messaging me. What is wrong here? And you can actually see like how it's just removing like the column that are in the row backwards, and again trying to figure out a better way to place it in other positions. And if it cannot, it will just return false every time, and eventually will return false and show that that the solution doesn't exist. You can place it like here, and now you can actually see the full power of this code. This algorithm is really slow, like in acting in exponential time or something, but it gets the job done. And there are some reasons why we still use like in TSP. I'm trying to. It's been over 6 months, and I've been thinking about making a video about traveling salesperson problem, and I also had the idea that I'll just create like this algorithm. Now you can actually see so all the 8 blocks are posted just like this one. There is no one in between the paths. We just try everything, and you cannot find like how flaw in this code. This is how it should be positioned. It doesn't matter that it doesn't encounter as a queen. Yep, 2 are still there. I think I removed them. Okay, I printed it. I'm not gonna do it again, but you get my point. Like you just have to take this code and paste it here. Like, yeah, I will do it. I will do it. Why won't I? Like here, just that. Then you will have this. So this is how the queen should be placed. You can do better. You can just Google the image of a queen, and you know what? We have been like over now. What, an hour and 5 minutes. So why not? Queen chess image. Like why not? Like why not? So I'll just speed this up and don't have time for downloading the image. Let's just check whatever we are getting here. Okay, and come on, what do we have it or not? Here we have it. Let's rename this, and what we can do is, oh no, like I have to now place that image at that particular point. Yeah, I don't want to do that. Let's see. Uh, Queen equal pygame dot display dot transform. Also I need like pygame dot display dot image queen. I'm not even sure if that is right. Let me see, it is PNG or JPEG. It is PNG. Queen dot PNG, comma 100 cross 100, and I really don't know if that is how you place it. which I totally don't remember. Pygame image resize. Let's see. So pygame.image.load, pygame.image, pygame.transform.scale, pygame. I was gonna make big mistake here. Scale and pygame.image dot load, and so we have our image now. And what we do is how to paste the image. I want to see screen.plit. Yeah, I remember now. So what we can do is when dot plit, we have like the queen image, queen, and mean the position. So I into 200 and j into 200, and I hope this looks like, come on, like work here. Not to be transform, what? Not this, but let's do it. Now what? How much can a guy mess this up? Yup. Now you can actually see. This is actually more beautiful. It already deserves like extra 5 minutes. Or should we let this play, or should we just move on? Well, you wanted to see like the ones, not to two, so let's do it. And don't want you guys to ask more videos. And no one asks actually, but please, I have exams. This is gonna take a while now. Can't believe like this algorithm took like 1 hour. Like if I had to speed this, the whole process up, it was gonna take like 2 hours, 20 minutes, 10 minutes. Why isn't Queen placing? What is wrong here? Why? Where are the queens? Blade dot queen 200 J 200. What? What is wrong? Can I can't have more than one image or what? One window. I can't have one queen here. So what I want to do is just create an array here. What I want to do is a dot append I into 200, comma j into 200, and for, let's see, circuit maker tuple, and what I do is for a in, for I in a, you can just make it like I here, and so this is gonna solve this thing a lot easily. But these indices must be integers or slices, not tuple. This what? Where? Line 23 here. 4. Okay, let's try it like this. How does it work? What? Invalid syntax. How? Mhm. What now? What? A list indices must be integers or slices, not tuple. How are they tuple? Let's do it like this. Range n a. Okay, we can do is a I. I think this will do it. Come on, yeah. Come on. Oh, how did I mess this up? How can someone mess this up? I feel like a biggest idiot in my entire life. You know, while I was coding, I made the same error. Like when I was like first writing the code, like this was the second time I writing this code. I made the same error. I put 200 here again. Okay, let's see if it actually does something. Okay, guys, this is where the coins can be placed, and you'll get the answer. So, guys, if you like this video, comment, subscribe, press the bell icon, and I hope I see you whenever I post the next video.